All right. Welcome, everyone. Thank you for sticking around for the talk before lunch, which is probably the most difficult talk track of any conference. I have good news for everyone, which is that this talk should only run about 40 minutes. So you should probably be the first ones in line for lunch, much ahead of the other talk that's going on. So you chose the right one. Congratulations. And if it's really bad, you can just leave early and be absolutely the first ones in line. Cool. All right, let's just go ahead and jump right in. I'm gonna give a little bit of background and then we're going straight in. So my own background, I started out in pen testing, security consulting, security research. If you know NCC Group here in Europe or ISEC Partners in the US, I was there for a long time, built out a few of the offices in the US with ISEC. And then after they got acquired by NCC Group, got offered a really interesting opportunity, which was to go be the first CISO at Etsy. And I'll get into why that was actually really interesting in a second. But I built and ran the 4 different security groups there. So application security, infrastructure security, and then security engineering and risk engineering. And after that, at the time, it was Etsy in New York and Netflix in California that were pioneering what we now call DevOps and the shift to cloud. So it was myself and one of my friends, Jason, over at Netflix, who were really the first CISOs to go through this shift to DevOps and cloud, which was really interesting, we will say, to put it mildly. But there were a bunch of things that we really learned out of that shift. And that kind of flash forward to today. My co-founders and I took those lessons learned out of Etsy about how do we defend web applications, APIs, microservices, especially if you're going towards DevOps or cloud. How do we have a more effective way of defending those? So we learned a bunch of things at Etsy. We took those lessons and we turned them into a product, which is Signal Sciences today. So it's what the marketing folks would call a next-gen WAF or a RASP. So if you've worked with Imperva or F5 or Akamai, and you're sick of them breaking all of your stuff like we were at Etsy, we built a product that actually solves a lot of the problems there. That's not what this talk is about. No one needs yet another vendor pitch. I'm happy to tell you about it later if it's interesting, but this talk today is really about the lessons learned moving from the world that we were all in, the kind of waterfall and data center world, to moving to DevOps and cloud. And really, this talk is the talk that I wish I could have given myself on day one of that transition, because while a bunch of these lessons will seem very obvious in retrospect, they were very difficult and painful to learn at the time. So hopefully I get to save you from a bunch of pain that I had to live through during this shift. And the conclusion really right up front, just the spoiler of how this actually all ends up, is that security fundamentally shifts from acting as a gatekeeper and as a blocker to focusing on enablement and really focusing on how do we enable teams to be secure by default. This is a fundamental shift in the way that we have done security. And this is really the only way in which we can be successful if we're going through this shift to DevOps and cloud. So what has changed? I'm curious, for my own knowledge, how many folks are in an organization that is thinking about going to cloud or going to DevOps or already there? Okay, good. You're in the right talk then, first of all. That's fantastic. So I think I won't spend much time on background here then. We'll just jump into the good stuff. But I think the most relevant bit is that change is now happening multiple orders of magnitude faster than it used to. So deployments go from maybe once a year or maybe twice a year down to every month or every week or every day or anything like that. It was made very apparent for me where my last day as a pen tester and a security consultant, I was at a big US healthcare company, and they made changes to their application in production once every 18 months. And I left there on a Friday. I took no time off because I'm an idiot. And I started at my new job on Monday morning at Etsy. And they sat me down and said, we make changes to our production applications 20 times a day. Figure out security. Go. So I did the respectable thing, which is go find a bunch of whiskey as fast as possible and just start drinking that, because I thought that was really the only way through getting security to work in something like that. But what I really learned out of there is that we used to have many injection points for security during this kind of slow moving process, and that drops to very few, and it changes the way that we think about securing applications and defending applications. Really, it goes from this kind of decentralized ownership of deploying software where one group writes it, one group tests it, another group looks for security issues, another group puts it to pre-production and tests it there, and finally another group actually moves it up to production, to the developers writing the code are the same ones deploying it directly into production. Now, that doesn't mean that we stop testing code, or we stop looking at the performance of that code, or we stop looking at the security of that code. It just fundamentally changes where these used to be outsourced groups. Now they are functions of the development teams actually writing the code themselves. So there's really two things that change with that. It changes the technical controls that we do for security, which is what this talk is about. So changing static analysis and pen testing and scanning and things like that. But it also changes the culture of your security teams and how security teams should interact with the organization to be successful. And so that's actually what that talk is right there. If you want, don't worry about writing the links down or anything. I can just send you the slide deck, and there's actually a more up-to-date version of it. So you can just email me afterwards, zane@signalsciences.com. And I'll send you the culture deck as well if you want that. So the big change here is that security can no longer be outsourced to, right? Traditionally, security has been this isolated group where development teams will write code and then they'll say, okay, great, you go scan it or look at it or tell me bugs to fix, and maybe I'll fix them, maybe I won't. What fundamentally changes here is security is going to the model that performance really had to go to, which is that how many folks know of tools or use tools like App Dynamics or New Relic or Datadog or any sort of performance tools like that? Anybody? No? Okay. Right. So these are tools that really, performance used to be a very specialized field where you would write code and it would go to a performance team who would look at it and say, oh, you could adjust this or you could adjust that to make it faster. Very much like security, where people would write code, it'd go to the security team and they'd say, there's a flaw here, there's a flaw here. What changed with performance, and I'll go into this more later on, but what changed with performance is that the rise of these tools like App Dynamics, New Relic, Datadog, all these other ones, they took what used to be a specialized field and brought visibility into it where the development teams could actually own that themselves. And they could look and see, oh, this code that this new API that I just shipped is actually really slow over here, so I'm going to go fix it. That's where we're headed with security as well, is that we have to give development teams and DevOps teams and really the broader business the ability to be security self-sufficient. They have to be able to own the security of their own services. Otherwise, we're not successful. This is the only way security becomes successful in this kind of DevOps and cloud journey. All right, so I'm going to start off with a highly technical flowchart of how, if we don't adapt our security approaches, what they look like in DevOps. So you have the security train shouting about safety and plowing into the DevOps car while very concerned about safety themselves. This is probably the best example of the security industry. I say as someone who's been in the security industry his entire life. I think that sums it up very well. So our actual agenda here today, for any organization that's writing software, these are generally the pieces of your SDLC, which would be your security development lifecycle or your software development lifecycle. But you're probably doing some sort of training, some sort of threat modeling, some sort of review and static analysis and things like that. Which of these actually need to adapt the most? Well, these are the ones that we're going to talk about today. So all of these pieces change, but this is only a 40-minute talk, so there would be no way to get through all of these. So what I'm going to do today is focus in on these particular sections: static analysis, dynamic scanning, visibility, feedback, and continuous feedback. But again, just because we're not talking about some of the other ones doesn't mean that those don't change. If you have questions about those, I'm more than happy to go into those at the end. All right, static analysis. How many folks have last time I asked you to raise your hand, I promise. But how many folks have worked with static analysis tools before? Yeah, condolences. We all have. It's one of the reasons we drink. But it's the first time that you turn on a static analysis tool, the record that I've now heard from a fellow CISO is that they turned on a static analysis tool that resulted in a 13,000 page report the first time that they ran it on their code base. So this is not unusual, right? Static analysis usually was a very slow control that took kind of a long time to try to adapt. That's the smart ones that are getting the jump on lunch early. So don't be the last ones to lunch right there. Definitely leave early. So static analysis, how we've traditionally done it is very heavyweight, right? We would turn on static analysis. We'd run it once a month or once a week, and it would result in this really huge report that for a lot of security organizations, what they would do is they would run that report, they would forward it to the development team and say, hey, there's 7,000 issues in here, go fix it. And the development team would say, yeah, why'd you send me a 200 meg PDF report that's all full of false positives? They would mark it as spam and never read any emails from security again. So, I mean, the way that we started it was kind of top down, where you search for everything at once, and then you try to slowly refine to eliminate false positives. But the funny thing is, this was kind of acceptable enough in a waterfall world, because if we were only changing our applications once every 18 months, and it took us 2 years to slowly refine our static analysis tools, well, we only really missed 1 release or 2 releases. And so it kind of worked. But how do we actually adapt this? So what we do is we shift from a very heavyweight top-down model to actually a much lighter weight bottoms-up model. And what I mean by that is you identify very specific classes of vulnerabilities that you're most interested in, and you start with only those. So rather than saying, analyze our software for every bug that you could possibly try to find, what you do is you say, look, to start, I only care about command execution. So let's look for those. Let's see how fast we can make that. Now let's add something for SQL injection. Now let's add something for cross-site scripting. And so you focus on enabling velocity, because ultimately, if your development organization is going to DevOps, going to cloud, they need the velocity to be able to run a control like this that used to take a month. They need to be able to run it on every code commit, right? So you're talking multiple times a day. So that's kind of the methodology. A specific example would be pick something like command execution. That's a great one to start with, because there's only so many ways that you can actually introduce code execution flaws into a code base. It's usually pretty small. It's usually like a half a dozen ways, versus cross-site scripting or SQL injection that can be really complex. So start with ones that are very simple and just say, great, we're only going to scan for this. Now we're going to scan for 2 things like command execution and directory traversal. Now we're going to scan for 3 things like cross-site scripting as well. Because the focus is not only on your findings, your focus is on demonstrating to the development organization that something that they have seen, whether it was in your organization or at a previous company, that they've seen be very slow and very painful and very heavyweight. You're showing that you can still get security coverage, but in a way that actually functions very quickly. And so you're showing that, look, we're not going to have to throw out all of our security controls just because you want to ship software faster. We actually agree with you. Like, shipping software faster is actually better. So let's show that security controls can actually keep up and enable you to do that. So I'm going to give 2 other examples here of ways in which we can turn the static analysis problem and actually use it for a couple things that are really cheap in terms of time and money. But really effective, actually, for organizations. So the first one is identifying when certain types of code showing up in the code base should drive a conversation. So the examples that I give here are things like hashing or encryption or file system operations. What that means is, if you have developers writing a new API service or a new web application to work with your customers, if a bunch of encryption code starts showing up in there, it's not something that you want to block, but it is something that you want to know about, right? It's inherently security sensitive, and it's something that can really drive a conversation. We can say, kind of in the old model, you might say, look, we want to ban old broken hashing algorithms like MD5 or SHA-1. And so in the old model, what you would do is you'd say, if a developer tries to commit code with MD5, they get a message back that says, you're not allowed to do that. You have to use a new modern hashing function like SHA-256. The problem is, and that's not wrong, you don't want to allow MD5 in the code base, it's old and broken. But the way in which you could actually do something much more useful is you can say, hey, if we see someone trying to introduce any hashing, whether it's MD5, whether it's SHA-256, anything, that should send up a flag. And that flag should say, we want to go talk to that team to figure out what's going on. Like, why are they actually trying to hash something here? What do they think is so sensitive? And so that flag might go to the security team. It might go to your development leads. It might go to your chief architect or your CTO. But it is a great sign that something is going on here that is interesting and worth a conversation. And so if you do that, it can actually, I mean, when we first tried this at Etsy, I did not expect much out of it. I thought it would be a halfway useful thing. It ended up being tremendously useful, actually, because we found a bunch of cases where development teams were going to collect whole new sets of user data that we knew nothing about. And they said, hey, we're trying to do the right thing. We want to protect it. So we're trying to hash it. And we'd say, okay, here's what you're collecting. Here's how you're going to be storing it. Here's how you want to protect it. Okay, great. Actually, what you want to do is use a totally different encryption function instead of hashing. And we've written one internally already where you can use it. You don't even have to manage keys. It's even better for you, and it protects the data better. And it's something that we never would have known about if we had just said, oh, you tried to use SHA-1, you use SHA-256 instead. So using this as a means to detect areas where there's interesting spots to have conversations is a super useful form of static analysis. The other one, and the final one here on static analysis, is it's kind of a similar concept, but applied in a different way, which is rather than certain sensitive types of code, like hashing or encryption or anything there, knowing when there's certain sensitive portions of the code base itself. So every application or API or anything like that has things like this, where it's usually the role-based access control or the session management or the kind of core security or authorization services of the app. And those typically get written right at the beginning by like the lead architect or something like that. And then they almost never get updated because they're a core part of the app. And once you write them, they're correct and you don't need to change them. So what you want to know as either a developer responsible for security or as a security team, you want to know if something that should never really change is being changed. And so in the old model, what we would all tend to do in kind of a waterfall world is we would say, okay, these files are protected. If you try to change them, you need sign off from these 5 people before you're allowed to change them. And that's the way that we protected them. The problem is, as you're going to a more DevOps sort of world where things are changing more frequently, those files will eventually get changed at some point. And what will actually happen in practice rather than in theory is someone will need to change one of those files when there is a major incident going on. It might be that your service is down or that you're under attack or something like that. And the first time that a senior engineer rushes in to change one of those files when they need to because everything is going wrong, and there's a security control that says, nope, you're not allowed to change it. You need to go get sign off from these 5 people first. If you're a security person, you are about to have a very bad day afterwards. What's going to happen is they're going to rip out every security control after that because it stood in the way of making a critical change at a critical time. So the way that we rethink this sort of approach, where we still get all of the security coverage, but we're not introducing friction and slowing things down, is we say, okay, if anyone needs to change any of these files, rather than waiting for sign off, what it says is when someone tries to make a change, our source control says, okay, if you're changing this file, it's very sensitive. So if you actually make this change, it is going to alert these 5 people. And that might be your CTO and your chief architect and your CISO and very senior people in the organization. And what this allows you to do is still get coverage over that. But if that's a senior engineer who's making that change, they say, yeah, no problem. I've already talked to them. Allow me to make the change. But if it's your intern or a brand new engineer who's accidentally changing the wrong file, they are very quickly going to say, nope, sorry, wrong file. I do not page the CTO at 3 a.m. because I'm working on the wrong file. That is usually what's known as a career limiting move if you do that. So typically it still gives you that sort of coverage, but it allows you to move quickly. And it really, all of these things, if there's anything I hope you take from this section, it's thinking about controls that used to function as blocking and think about how can we still get alerting coverage on them so we still don't lose any of the coverage, but we enable the organization to move quicker. All right, that's it for static analysis. Moving on to dynamic scanning. This meme has no relation to dynamic scanning. I spent hours trying to find a security-related meme for dynamic scanning and found nothing. So if you can find something for dynamic scanning, you are a better speaker than I am. Congratulations, and please send it to me. So we used to do, and when I talk about dynamic scanning, I mean the software that you would try to point at your website and it would try to crawl it and then inject a bunch of random data into a search field or something like that and try to find bugs that way. So commercial tools were usually like AppScan and Web Inspect and things like that. And we used to treat this as kind of a way that said, hey, we're going to scan our apps, and if they can find issues, we should fix those issues pretty quickly. So how do we adapt that? Well, the problem is those scanners were written for the waterfall world. They were written for apps of the early to mid 2000s. And the problem is modern applications just function so differently than the applications of 15, 20 years ago that scanners, for the most part, just aren't really that worth it anymore. If you look at modern applications, right, it's a lot of single page applications, or they're very heavy on JavaScript and things like that. And the problem is, I'm not saying that you can't make scanners work or that they have no value. It's that for any of us that are in security, we all have so many projects going on that you can spend a year trying to get one of these things to work and never actually get anywhere. And you would be much better off using that year somewhere else, right? Focusing on other projects you can actually get completed. For some organizations are able to really make effective use of scanners. When I talked to a million different CISOs going through this DevOps shift, this was a pretty uniform opinion that scanners have really dropped off in their effectiveness and usage. But there are two actually cheap and effective ways that you can still use them that are really useful, actually. One is ensuring that policies that you're putting in place are actually being enforced. So if you're saying things like all of our customer-facing applications have to be served over TLS or SSL, great. First of all, good choice. But second of all, you can then use scanners to say, I want them to continuously crawl all of my applications and just alert me if they ever see a link that's plain text HTTP and not HTTPS, over TLS or over SSL. Really cheap, really effective. It can just run continuously and alert if there's ever anything there. The other is really on a control on ensuring that previously discovered vulnerabilities don't show back up. So let's say you had kind of a typical bug where there was a cross-site scripting issue in your search box, where someone typed in HTML in that, it got reflected back, and there was an attack that way. So scanners, you fix that bug, great, everything's good, but you can use scanners to say, I want you to always go to this one form field and try this one attack. And if it ever succeeds, I want you to alert me. And so you actually get 2 for 1 out of that, because if your scanner goes and finds that again, and it means it shows back up at the code base, it means, first of all, you've got a problem because that vulnerability is back. But number 2, it means that something with your testing is actually broken, because after you fixed it, developers added a test for that. And that means not only is there a new or an old vulnerability, but also the testing is broken as well. So it's a really cheap and effective control there. All right, next section, security visibility. This is a sarcastic Twitter feed that, if you've ever worked in web operations, is painfully accurate and sarcastic and funny. Otherwise, it just seems weird. Okay, security visibility. How have we had this in the past? If we're being truthful, the answer is that we really haven't had security visibility in the past. We've had very isolated and siloed pockets of data. So we've had logs, maybe with our operations team, and customer service reports saying, oh, I'm getting malware from your site that might go to your customer service agents, or things that look like outages paging a development team, but not a security team. But each of these sources of data was completely siloed. And so how do we change this? The really good thing here, and this is a lot of what I alluded to at the beginning, is that security is just starting to learn the lessons that the development teams and the DevOps teams or operations teams had to learn at the start of the rise of DevOps. The reason that DevOps has been so successful and will continue to be successful is it took isolated bits of data where everyone needed to independently do things to get a job done, and it brought the context together where everyone had the visibility in the context to be able to move much faster. And so software could ship faster, the business could release new products faster. This is why DevOps has really been successful. And security is just starting to learn the same lesson, which is that we need to take things that were previously siloed and bring them together so that everyone can own security as part of that. So it's great in theory, but let me actually give you an example, which is take this graph. So HTTP 500 errors, that's just a generic error in a web application or an API. It just means something went wrong. But the very interesting thing that I had to learn firsthand is that if you ask different teams inside the organization what this implies, you will get completely different answers. So if you ask a development team, hey, what do you think that means? They'll often tell you, oh, yeah, we had the new intern had a bad code deploy and it broke the application and then we reverted the change and now everything's okay. If you ask the DevOps team what that means, they'll say, oh, that's the 4th time I've been paged this week. I've stopped even paying attention. I'm sure it was this one development team who broke something, whatever, I don't care about it. If you ask your security team what that is, they'll say 500 errors. That's interesting. I wonder if that's somebody discovering a vulnerability and working on their exploit payload before they get the actual exploit working. And if you're ever fortunate enough to ask your attackers or your pen testers what that implies, that is them saying, oh yeah, that was me discovering a vulnerability and I was working on the exploit before I actually got it working. So what's missing here is security relevant data for everyone. And so all of those different answers, those immediately go away if you can bring security relevant data where any one of those groups can look at this and say, wait, why are those errors happening at the same time that we're seeing more attacks than we've ever seen before? Like, that is actually really interesting. Maybe it's not a bad code deploy from the intern. Maybe it's not a development team that always breaks something. Maybe it's somebody actually discovering a vulnerability here and we need to see what's going on there. And the fact is that any one of these groups can now look at this and have the context they need to see that this is actually a very security relevant event that is actually very important. All right, moving on to feedback. Office Space, I looked this up, this movie is now 19 years old. So first of all, I feel incredibly old now. And number 2 is that this now qualifies it again to be included in slide decks because it's been 19 years. And it was the first .com bubble that everyone had these all in slide decks. So we're allowed to bring these back again. Feedback was typically done as annual pen tests in the past. I say this as a former pen tester. How many folks have done either performed pen tests or had pen tests done with their organization? Right? It's kind of the standard thing. You typically do them once a year, right? And you typically have a few people for a few weeks. The problem is we're all stuck in a trap with that, which is when you're getting pen testing done, you either have to ask your pen testers to go very wide, but only a little bit deep, or ask them to really focus on one area, but not cover anything else. And your pen testers don't want to see the problem there. You see the problem there. It's a fundamental limitation of pen testing. And so this is where the rise of, it ultimately only answers the question, do I have bugs? And the answer is yes. If we're writing software, we have bugs. End of story. So how do we actually adapt this? This is where bug bounties have really started to be tremendously useful. So I want to be very specific, which is that bounties do not replace pen tests. They are not a replacement for pen test at all. Bug bounties, for any folks who don't know it, I realized I didn't define the term. So bug bounties are where you put a policy out that you say, for any security researchers on the planet, if you want to try to find security vulnerabilities in our websites or our infrastructure or any of our services, if you play by these rules and only look at these systems that are in scope, if you report those issues to us and you act in good faith, we will reward you in some way. That reward might be money. It might be just sending them a t-shirt. It might be just putting their name up on a thank you page. It can be anything with that. But the reason that these launched are because historically, and not to spend too much time on the past here, but historically in the past, if you were a researcher who reported an issue to a company, you had 50-50 odds of getting sued by that company. And so a lot of researchers, especially those of us who went through pen testing years and everything, for a lot of researchers, if you found an issue with a company, you might just publish it anonymously because it was not in your best interest to actually report that because they might sue you. And so everyone would lose out of that scenario. The researcher would lose, the company would lose because now there's a real issue that's just been published to the internet rather than being sent to them to fix it. Everybody lost. And so bug bounties were really a reaction to that said, hey, we can actually build a system where everybody wins. And this is the system where researchers, if they do the right thing and report the issue and play by the rules, they can get rewarded. So the company gets, issues that they can fix. The researchers get rewarded and thanked in some way. Everybody wins. Early on, you started to see some organizations think about maybe replacing pen test entirely just with bounty programs. I really would not recommend that. I really see the two as things that complement each other and make each one stronger. Because if you run a bounty program, they're very good at going broad. So they are the piece that can kind of test a lot of different things, but they don't tend to test them that deeply. And then that allows you to use your pen tests in the best possible way, which is focusing them on particular areas that their skills are very focused on or that you're particularly worried about. And so now you can get both the broad coverage and the deep coverage, and it really, the two combine to actually make something really effective there. So, all right, getting into the final section here. This is really a few thoughts on what I see the best organizations, what is the commonality between those organizations? So places that are going through cloud and DevOps, what are the things that they are all sharing in common that they're doing right? And the number one piece is really focusing on this kind of continuous feedback and continuous visibility, the ability to give everyone the context to see security relevant data. The real way to be thinking about this at the end of the day is security, it's not magic. We're up against real attackers, right? And so if you want to be successful against real attackers, you have to be able to answer the question, how do I know when my attackers themselves are being successful? The first time that you ask yourself this question as a defender, you're not going to like the answer. Or you're lying to yourself and then you like the answer. But you say, oh, we detect them, we're fine, we bought a firewall. The actual answer is, for most types of attacks, we would have no idea when the attackers are actually being successful. And so when you start to ask yourself that question, it really starts to guide where you want to focus your defensive resources on by saying, okay, for this type of attack, we would have no way of detecting it. Let's focus on that for the next 6 months. Okay, now we've got something in place. For this type of attack over here, we'd have no way of detecting it. Let's focus on that for the 6 months after that. And what you start to come to is, and this was a realization that took me probably 6 months to a year to figure out at Etsy, which was that, and this was very controversial at the time, and I really did not believe it myself in the beginning, was that actually this shift to DevOps and cloud can make us more secure. At first, when you're going from a waterfall world to where things are changing all the time, it seems like it's going to make you much less secure. It's going to be super dangerous. It's going to be super scary. The reality is it can actually make us more secure if we do it right. And the reason for that is three things that I'm going to go into. One is the ability to detect your attackers as early as possible in the attack chain. So because we start to focus on this visibility and bringing context for different teams, you can start to detect your attackers before they've been completely successful, right? Right now, most organizations find out that they've been breached because the New York Times calls them, or the BBC calls them and says, do you have any comment because we're about to run a story that you've had a massive breach? That's not a good way to find out that you've been breached, right? What we want to think about is how do we get visibility to find out that the attacker hasn't actually got to our data yet, but is moving laterally through our network or is doing command and control back out to a service that they own. Number two is that as you're going into this DevOps world, it gives you the ability to continuously test and refine your triage and response. So what I mean by that is you can say, okay, let's run an example where either via a bug bounty or via an attacker, we assume that an issue was discovered in some service over here. Okay, if that was real, who do I actually talk to inside the organization to get that fixed? The first couple times you run this exercise, you'll run into super legacy applications or infrastructure where the team that wrote that left the company 10 years ago. Who owns that? Nobody owns it, which means everybody owns it, which means nobody owns it. So the first time that you run through those sort of exercises, it's tremendously useful because it will be very confusing and you'll have to figure out those problems. The important point is you want to figure out those problems when it's an example that you control and not an attacker who's in the middle of exploiting your service and stealing your user data. If you have to figure out, how to use a fire extinguisher and where the exits are because the building's on fire, you're in trouble. But if you've looked ahead of time and said, oh, look, there's green signs. It says there's exits here. Okay, great. Now if there's a fire, I know I can run through that door, right? And so you want to prepare ahead of time for these sort of things. And then finally, and kind of just a different take on that second point is it allows you to continuously test and refine your incident response, security operations, DFIR process, where you can say, what if there had been an issue in that service? Not only who do I talk to, but how would I do analysis that says, did they exploit anything else? Did they actually get to our data? Was it a bug bounty participant who found 8 very severe issues and then reported just one low severity issue, and they're actually exploiting all of the others, right? The first time that you ask yourself these questions, you're not going to like the answer. And that's incredibly useful because it now gives you, it gives you the prioritization that you need to focus on, okay, what do I need in place to be able to answer these things? So lots of security is doom and gloom and everything is broken and bad. I want to do the opposite and actually leave you with a good story here, which is something that happened to us at Etsy and is actually, the full story is up there on that link. I can send you it, or the slides will be online. But this is a story where an attacker was trying to find vulnerabilities in one of our services. And because we had run through those scenarios and didn't like our answers and started to invest and think about how do we get visibility into these services, we were actually able to detect them discovering a vulnerability before they got their exploit working. And so we detected that they had discovered a vulnerability, and we actually pushed a patch for that vulnerability before they even reported it to us. So they detected a vulnerability, they started working on it, they got their exploit working, and then they wrote an email when they were testing the exploit. They're like, wait, it just stopped working. Why is it not working anymore? They emailed us and they said, hey, I can't imagine that this was a coincidence that my exploit suddenly stopped working in the middle of everything. I was actually testing your service from my home IP address. I promise I was going to report it. Please don't call your lawyers. I promise I'm a good guy. And so we actually had this really fun back and forth interaction with one of what we thought was an attacker, but turned out to be a really nice security researcher. And they did a whole write-up about it, which was fascinating because you never see this sort of stuff actually written online, where they talked about discovering the vulnerability, how it stopped working, how they reported it. And I give this example not because, oh, we were so good or something like that. It has nothing to do with us. I give this example because this is where security, when we're going into this DevOps world and this cloud world, the fundamental reason why it's safer, why we can actually make things better with security here is for the first time, we can move faster than our attackers. If you think about the waterfall world and someone discovered a critical issue and you've got to ship a fix in 12 months, well, it doesn't take your attacker 12 months to exploit the issue. But if you're now going to a world where you deploy your software or make changes to production every week or every day or every hour, you can actually move faster than your attackers for the first time. And so for the very first time in our industry's history, we actually have the chance to move faster than our attackers and actually achieve our objectives better than them. So conclusions, security, if I had to sum it up in one way, it's that security is moving from this kind of gatekeeper blocker mentality where it tries to focus exclusively on how do we get rid of bugs before the software ships, which is fundamentally impossible. Bugs always exist. It doesn't mean we stop doing that, but we shift our focus to actually thinking about how do we provide visibility and feedback to the development teams and DevOps teams so that we can make the rest of the organization security self-sufficient. That's the goal that we're actually driving towards. So you're all awesome for sticking around the talk before lunch. Thank you for coming, and I'm more than happy to go into, we've got a bunch of time. I'm happy to go into questions, please. Even if it's just heckling and saying, these are the worst memes you've ever seen, by all means, grab the microphone. Let's have some fun here. There we go.
Oh,
All right. The brave soul to go first. Thank you.
So you're saying that early detection is core part of what you said, but intrusion detection is not like the easiest thing to do.
Oh yeah.
And I mean, how did you propose a big company or someone that has a really wide window of attack detect subtle attacks?
Fantastic question. I mean, we've mostly been doing it wrong for the last 20 years. That's why it's so difficult, right? I mean, I remember in job interviews, 15, 20 years ago, the first IDS question you'd ask someone is, oh, do you put a IDS outside the firewall or inside the firewall, right? And it's like, oh, well, do you want to see everything, but then it's too noisy, and do we put it there? The problem is when you're trying to when you're thinking about intrusion detection, and this is something I could spend 5 hours on, so I'll try to just keep it at 30 seconds, is that you look at most of those technologies and they were based on signatures and regular expressions, right? Looking for, did an exploit get sent where the shell code matches this particular signature, and let's try to detect that. Well, it fails in both ways. Number one, actual networks are very weird places where stuff like that happens all the time, and you'd never know that until you actually work in them. And number two, that's not how attackers actually operate, right? This is what I think is so important, is really thinking from that attack-driven model where your attackers don't care about sending an exploit from one internal service to another where your IDS is watching for that. They tricked your junior engineer into giving up their credentials, and now they log in just like every other engineer with that stolen SSH key, right? You don't need to send an exploit for that. We had an example where we ran something called we called them attack simulations, where rather than a traditional pen test where you're trying to find, vulnerabilities and then report those vulnerabilities there and say, patch this system or upgrade this OS, what we did is we turned over a developer laptop to our pen testers, our attack simulations. And we said, great, no one has any knowledge this is going on. Try to get our production data, go. The first time you do that, it is a humbling experience, we will say, because you're like, okay, we invested in a bunch of stuff here. We're going to totally detect them running Nmap across the network to map everything out. And then it got 3 days in, and we're like, man, these pen testers are super slow. Like, we haven't even seen them yet. Then why haven't they done anything? And I get a phone call that says, great, we've got all of your data. I'm like, but you didn't set off the very shiny IDS alarm. Like, how did you do it? And they're like, oh, well, it turns out you have an internal wiki where you've posted all of your network diagrams with no authentication. So we don't need to scan a single thing. We just went where your engineers went and looked at your network diagram and said, okay, there's the production systems. We're good to go. And the reason I tell that story is exactly to your question, which I love, is the way that we've thought about detection and visibility is not the way in which people actually attack systems. And so when I'm talking about detection and visibility, I mean we need to fundamentally change the way that we do it, and not just buy more IDSs and try to plug them in everywhere. So very long answer to a short question. I'm sorry, but one that I'm very passionate about, definitely. Please.
Thanks, Zane. Since DevOps is a new way of approaching IT, it's totally different from traditional IT. Mm-hmm. How do you convince people, legacy IT managers, for example, and also security staff to this new approach?
Yeah, it's a great question, right? How do you convince people to go to this approach? Well, there's good news and bad news. And they're the same thing, which is that it's happening anyway. So let me tell you what I see in organizations. Sometimes the security organization says, okay, we recognize this is going to happen. Let's figure out how to change and adapt with it and really empower it. Plenty of times, you also see a security organization that says, no, we're not going to allow it to happen. Who do you think wins, the CEO or the security manager? CEO, right? And so the business wants to move faster. And so what you see is security teams then just get ignored and routed around, right? I see this now very often where I'll chat with a CISO in an organization like that, and they'll say, "Oh, we don't do cloud here. It's unsafe." And you go look at their website, and they have 15 open engineer roles for cloud engineering, and they talk about how they've been operating in the cloud for 4 years and everything like that. And what's happened is the CIO or the CTO or the engineering group, I'll then have a conversation with them, and they say, "Oh yeah, we just stopped talking to security 3 years ago." Because all they would do is say no. And so that's great. You're no longer at the adults table. The adults are going to go run the business over here, and security is going to sit over there and not be listened to. And you can do all your compliance stuff and have fun, but we're going to go move the business forward. And so the problem is everybody loses in that environment, right? And so really the way to think about it is this change is going to happen, whether the security team wants it to or not. So let's think about how do we adapt with it as part of it. I mean, my first 6 months, I thought it was a terrible idea and super dangerous. And I really had to learn these lessons. It's why I was, hopefully sharing so many of them with you here, is that it can actually make us safer. At the end of the day, it can actually make us more secure. So yeah, great question. Thank you. Other ones, please. Oh, you're up next.
Hi. About intrusion detection, you mentioned that we have to do things differently now, but you did not say exactly how. Is that a red team exercise or stuff like that?
Yeah. If you want to give me 6 more hours on stage, I'm more than happy to go through that. But no one wants to listen to me talk for 6 hours, even me. So I'll give you the short version, and I'm more than happy to follow up and talk on a bunch of that stuff. I'd say that the biggest fundamental shift is that it's kind of like, how many folks have heard of CrowdStrike and Cylance and Carbon Black and these kind of new ways of doing antivirus, right? There's a strong parallel here, which is the old ways of doing antivirus are, a bunch of signatures, and you'd run a hash on a binary and say, does this hash match anything that we know is bad? If so, block it. But the new ways of doing it are actually looking at something that's running on your system and saying, why is it trying to write to the registry in this certain way? Or why is it trying to look at SSH keys that are on disk? And it's looking at the behavior of what's going on. That's the way in which IDS and intrusion detection and just security visibility in general, it has to adapt in that same mentality. The old model was always signatures. Let's put a bunch of signatures in a box. Let's deploy that box on a span port on our network. And let's see if these signatures match anything going across the network. That's not how attackers actually attack systems. What you want to do is you want to think about the red teams and the attack simulations can inform you, but at the end of the day, you have to change your mentality from how do I check this security box or check this compliance box, and think about, for these top 5 most likely ways in which people will attack me, how do I have visibility for those? So like the example that I gave from our own past back at Etsy was like, okay, well, how's someone going to attack us if they weren't going to scan the network? Well, they'll probably go to the wiki and look for network diagrams. Let's go look at our wiki. Oh, there's no authentication turned on. Step 1, let's probably turn on authentication there. Step 2, let's start to get a little bit clever about this. And let's start to say the way that people look at network documentation, for example, the way that a new engineer does that is very different than the way that an attacker does it. An attacker is going to go download every file that they can find in there. So now I want to set off an alert that's not a signature. It's an alert that says someone just viewed 8 different network diagrams in 20 minutes. Your engineers don't do that, but your attackers sure do. And you start to apply that sort of mentality to different critical internal systems and think about it that way. So there's a bunch of fun tricks that were on camera, that I won't give right now. But I'm happy to share with you in a follow-up. But most importantly is just a mentality change, that rather than going from this kind of signature and blacklist sort of mentality, we have to start thinking about how people actually attack systems. And you can do some of that yourself, and you augment that by hiring kind of pen testers and red teamers and attackers to say, great, go attack, and don't tell me the thing to patch. I don't actually care about that. Tell me how you attacked the systems and what steps you didn't take, because that's just as important. I actually did a whole separate full talk on this that I can send you as well. It's called Attack-Driven Defense, and it's really about changing this model to think about, we need to defend systems against the way people actually attack them, and not just as a compliance mentality. So long answer, sorry. And still only touched on the tiniest % of it, but yeah, it's changing the way we've done things for 20 years, right? And so it's not going to be a a 2-minute answer. All right, everyone. Okay, sweet.
I have the mic. So your presentation was really interesting.
Thank you.
What I'm starting to see now is an illegitimate child of agile and IT for companies that does not make developments, but I have a lot of IT. I don't know, an hospital or something like that. And how would you adapt your methodology, your way of thinking, of having this global context for a security of a company that is not doing devs, but finally have a lot of ops inside?
Yeah, I mean, I think adopting mentality, first of all, you have to focus on adopting mentality first before you adopt technology or adapting technology, right? If you're trying to just buy new things but not change the mentality, it doesn't work. It's not successful. So I think to your question, the way in which you think about adapting mentality is really go look to other organizations that have gone through this shift already and see what they publish. Sometimes it's talks, sometimes it's blog posts, sometimes it's podcast interviews, but there's no reason that you should have to learn a very painful experience now when hundreds and thousands of organizations have already gone through the shift. Actually, at this point, tens of thousands of organizations have gone through the shift. Let's learn from each other on this because we're all really facing the same problems at the end of the day. And the more that we can help each other on this, the better. So what I do is I look for that. How can I learn from other organizations that have gone through the shift? And then the follow-up to that is I look for new technologies that have actually been built for that shift, right? The vendor that I was buying in 2005 almost certainly is not the right vendor to be buying in 2018, right? Because technology has shifted and vendors for the most part don't. And so really thinking about how can I bring in technology to support that mind shift that's going on as well. Please.
Hi, Zane. So maybe you've had some experience with this, but your stakeholders aren't just your necessarily CTO or CEO, et cetera, trying to push out more product. Sometimes it's also, for instance, external regulators or internal audit, et cetera, right?
Yep.
So fair enough. It's not just security being driven to change because the development group wants to move to DevOps.
Yeah.
It's also being able to satisfy then the needs of your, say, internal audit or external audit that
Totally
says like,
agree.
hey, I still want to see your annual pen test, right? So how do you kind of manage that, or how have you managed that in the past?
It's a great question, and the first couple of years managing my auditors was some fun learning experiences, we'll say. It's tough, right? Because by its very nature, regulation and compliance lags whatever is actually going on in the industry, right? Just inherently as part of it. And so, especially around security, the most effective strategy that I found, and this can manifest itself in different techniques, but the strategy I would find is speaking with your auditors so often, or regulators, whatever, so often they're used to what has been done in the past, like the control that you put in place is the requirement, but it's actually not. And this is where I'd start to push back and say, okay, let's talk through what the requirement here actually is. And then let me show you how we're achieving that requirement in a newer way than you're used to. And so if you get caught up in the thing of, oh, well, you need 8 different people to sign off on this release before it goes live, well, it turns out that's not actually the requirement. The requirement is multiple parties being aware of what's going on and kind of sign off in that way. So then you say, okay, well, here's how, even though one developer can actually write code and deploy it to production, here is all of the anomaly alerting and everything that we built around that. So if there is anything unusual, it notifies these 5 completely independent people. And so you get them, the trick I found with the auditors is to say, okay, great. Don't tell me the control. We all are used to that. Tell me the scenario that you are trying to put this control in place to mitigate, and force them to actually think about that. And then you can bring them around to, this is how we're achieving that objective, but in a newer way than you're used to. The reality is, it works 80% of the time. 20%, you're still gonna have the one like, I need to see this firewall change log. And you're like, okay, fine. Like if that's the one that you want, I know I'm gonna lose 20% here. Let's throw that in the 20% bucket. But you can actually push things forward a meaningful percentage of the amount of times. But you have to get you're doing new stuff. You can't expect your auditors or regulators just to show up and approve it. You have to get them to think about why does that control exist in the first place? Well, it's to prevent misuse in this way. Great. This is the way that we're achieving that, but in a slightly different way. And then the more you can point to other organizations in your field doing the same stuff, obviously the better. When I was going through PCI with a bunch of this, I mean, we were some of the first ones. So our PCI auditors were confused a little bit, I'd say there. And like I said, at first I was losing almost every battle there. And then when I started to actually do that technique of saying, hey, I want you to talk about why this control is important and what it's there to prevent. Let me show you how we're achieving that objective. The success rate really skyrocketed.
Okay, thanks a lot.
Thank you so much. I'll be around if there's any other questions. Otherwise, enjoy lunch. Thank you.